Hey, what's going on, guys? Komakikans here. A quick update on Wukong UCI chess engine development progress. So, I've written the sort moves routine completely, and the reason for doing this, I want to say there are two reasons for doing this, but actually there is the only reason for doing this. I wasn't really that sure if it works correctly due to scoring the moves on the fly, and as far as as I didn't really manage to debug that sort of assorted moves, other than keeping track of the overall number of nodes being reduced after the sort routine move, after the sort moves routine fires. Basically, there was no other way of distinguishing whether it works or not. But obviously I wanted to see like the moves and the associated scores before sorting, like they're randomly placed within the move list, and then I just wanted to see them after they got sorted. So that's the reason for rewriting this sort moves routine here. So now I've added a new array here that would be storing the corresponding scores for every single move. And the next thing, I just initialize this by scoring every single move within the move list. So just looping over the move list, and so it states like init move score array, but literally we just loop over the array of loop over the move list, and then scoring every single move within this move list, and that's how we initialize the move scores indexed by the count. Which is the index within the move score. So this allows us to have this move scores array to have a scores mapped from the current move list to this sort of an array, which means that from now on we can make use of our descendant sorting list algorithm, which I could try to make use of before, but that wasn't that clear. At least, again, like I wasn't really that possible. I wasn't that sure that it actually worked correctly. But now I'm just going for a classic descending order sorting algorithm here, and I'm doing two things simultaneously. So first, I'm swapping the scores, basically ordering them in the descending order, and at the same time, like simultaneously, I'm doing the same with our moves within the move list, because we are keeping track of this current and next indexes here that actually corresponds that so-called linked items, like move linked with the score. Obviously it's not linked like explicitly, it's just linked kind of like in our heads basically, but still they're kind of mapped there. So as far as they are mapped, we can actually do two things at the same time. So we can swap our scores and then swap our moves, and eventually we'll have the same scores still kind of related to the same moves, but the order of both scores and moves has changed from randomly placed moves and scores to descending order placed moves and scores. So I just want to demonstrate you this, and the good news is that from now on it can actually be tracked quite pretty instantly and straightforward. So if I just go to my console, make debug would run it a little bit slower, but doesn't matter really. So let's go to the very beginning here, and so here we have two lists been printed. So before sorting, we have the moves as they have been generated by the move generator, and here we have the associated scores. I don't say they has been assigned to this move. They has not been assigned like many embedded move generators do. Like when the move when the move is kind of like an object, which doesn't only have its value like encoded as an integer, but also has a corresponding score being stored within the move structure. But here we're just mapping them on the fly, but not the way we did this before, because here at least we make sure that even though we map them on the fly, still first we completely going for sorting moves first, and as far as moves are getting sorted, only then we actually started looping over those moves and just making them recursively. That's kind of that's quite pretty simple here. Well, okay, so this was before sorting, and now after sorting, you see like this moves has been ordered in the descending order. So let's find this E2A6, which had the score 10303. So let's, and this is it. So E2A6 and score 10303. So, and this is the same for all the other moves. So say F3, F6, 10, 201. So let's have a look. 201, F3, F6. So you see like this relations between the move and the scores are capped basically. So that's very simple and straightforward way of doing things. And obviously, as far as we're going within our iterative deepening, we have more and more values being available here. Well, this goes for capture, so I'll probably just explain this in a little bit more details now, probably here, because this, the move at the depth of 6, it has the most complete move order in here. So so what does this 20,000 stands for? So this is the principal variation move that always is about to be set up as the first move. And as far as we go and as far as we're using the iterative deepening here, we have a principal variation move every next time we go for like say we go for depth 1, so we already have a principal variation move. Then we go to depth 2, and again like we already have the principal variation move from the depth 1, and we're using this and placing it as the very first move to order the move list that is being generated on depth +1. So like in one level of depth deeper actually. So this is it. So we always have this 200s 20,000s being stored as the very first move, and this is happening because here within our score move I've replaced this principal variation move scoring from the quiet moves right over in here, because obviously if we have a principal variation move, we don't really want to do all this stuff. We just need to instantly return the high score for this move, so to make sure that this move would be the very first in the move list. And for all the other moves, first we take care of captures. So captures are ordered higher compared to all the other quiet moves, compared to the quiet moves, and we not only ordering the captures, but we also order the captures inside the captures using the MVVLV heuristics, which stands for most valuable victim, less valuable attackers. So to make sure that moves like pawn takes queen are stored before the moves like queen takes pawn, and so on. And then this 700 stands for the history moves, if available. But if they are not available, so this 7,000 means that there are no history moves available. But further on, as far as we are going deeper, these history moves are starting getting available, which is really nice. And also we have moves like killers, like the first and the second killer. And here in this particular position, we don't really have them. But if we just switch to another position, let's go my king position here, and I just want to print this position to the console. So print board. So to give you an idea of how this position looks like, basically. So should have been stored. at the very top of the output here. So this is the position basically, and this one already should contain some killers as well as the history moves. So well, it still calculates because in the debugging mode it doesn't really go that fast. Okay, it doesn't have killers in this position still. Well, this is a little bit strange. Well, probably I picked up the wrong position. I just really wanted to show you some killer moves here being scored as 9,000 for first killer and 9,000 for a second killer, for a second killer. So well, maybe I can use this killer position involving mostly only pawns. Well, this is really quite a bit strange, to be honest. Why I can't see no killer moves here? Well, I hope I didn't comment this out. Nope. Well, this is a bit strange. Okay, guys, just hold on a sec. I just really want to find the position where the killer moves occurring actually. Okay, guys, I just realized that obviously we don't have killer moves on the ply of 0, so we just need to change the ply, and basically regardless of position, because most, well, like, I can't say most position have the killer moves, but I just show you what I mean here. So let's search for score move, and no, here search position. So let's try the ply of 1 here, and again, like for those who is not aware of what the killer moves are, they are produced by the beta cutoff. So let's say a beta cutoff occurs before sorting. Okay, before sorting. Just wondering why it only prints this before sorting. This is a bit weird. Oh, that's because, okay, and here as well, like this. So now this should work. So yeah, now we have this after sorting. Okay, let's just try to look for 8,000s here. Okay, so here we got our second killer moves that are 8,000s or higher, and also let's have a look if we have any first killer moves. Yeah, so here we have some here. Okay, something has gone wrong with my Control Shift F stuff, so I have no idea why I can't search for it. Oh, maybe it just, oh yeah, here it is. So yeah, here we have a couple of killer moves. So yeah, obviously it depends on the ply. So this is what I wanted to share with you guys. The idea is very simple. So from now on, we can actually keep track of the move list before it got sorted and after it got sorted. And what I also can claim already at this point, that actually starting from this point, it plays really faster than TSCP and BLITZ. And let me just try to demonstrate you that. So I just get rid of this debugging, printing the debugging information lines of code, and save, and then go down here, enable the UCI stuff, the UCI loop to make it possible to play within the Arena GUI, and yeah, and I also want to compile this not for the debug but for production with some sort of optimizations, which allows the engine to play faster because it's compiled with this -o fast optimization flag. Okay, so we got our UCI driver working, and we can now already try to invoke our arena and have a look at the speed, at the time management during the BLITZ game versus TSCP. So just create a new game, and okay, we got, so it seems like TSCP is gonna be playing white pieces, and if it goes e4, we even have a chance to see, like, okay, if it plays e4. I remember there was one game, yeah, let's see this from Wukong's perspective. I remember there was one game that currently Wukong wins against TSCP with black pieces if white actually goes for e2, e4 as the first move, because TSCP is has various kind of openings. It's not really openings, but it's not always playing the same moves. So you can play e4, you can play d4 sometimes, so some sort of a random first moves from time to time. And even though the position for black would seemingly get really horrible due to this ugly double pawns and things like that, but this game, I'm not really sure this is the exact game I've been watching already, but it seems like. But this game, if this is the game I was watching, should end with a mate where black actually mates white king in a very, very beautiful way, basically. And I didn't yet analyze that game in great details, but it looks like quite pretty impressive. So at the moment it seems like white is better, clearly better, and basically I agree. TSCP thinks he's for about a pawn up from the positional perspective, and Wukong basically agrees. He thinks he's gonna a bit worse than TSCP here. So but even though that the black king has just castled where it potentially might get mate, it's still like no one ever did die due to the getting into check yet, so it's not a big deal really. And now the situation is gonna be changing in the favor of white, believe it or not. And yeah, now I can already claim that this is the exact game I've been watching, basically. And you see, like, these two pawns on e5 and e4, on e5 and e6, these pawns would get captured eventually, believe it or not. Yeah, so the one pawn has already been captured, and now it seems like the black are generating, the white are generating the attack and trying to mate, the black king. Even worse, it seems like white has just won the rook for a bishop, and it doesn't seem it's really like kind of like that, but still this game would be won by black, believe it or not. So, and now one little note here, that from the human perspective, if I would be playing this position as black, I would try to mate the black king. I would try to mate the white king using the weakness of the light squares. So just actually, I saw this after this move occurred. So we just put the bishop on f3 and then try to go with queen like to h6, then h3, and then just try to mate on g2. This could be a really good idea, but obviously the game is going slightly bit different way. Well, probably Wukong just doesn't see that opportunity, or maybe he does, but he doesn't consider that to be that great. But anyway, without any other evaluation adjustments or features other but the bare move, the bare material scoring, and just the positional p-square tables, giving an idea to Wukong of where to develop its pieces. It's quite pretty impressive that this bishop was blockading the pawn. Well, before the rook has captured it, it was kind of blockading the pawn. and this pawn is not going anywhere as well, and would I don't really remember whether it would get captured or not, but obviously it actually won't do any harm. And now this is a very interesting part that I really need to analyze. Wukong doesn't take this rook for some reason, so I'll need to figure that out later on, but it doesn't take. And by the way, have a look at the time. You see, like, Wukong's time is up on the clock quite pretty significantly, even though the depth, so TSCP is now going even for depth 5, well, he started with depth 6, and from time to time he was going to depth 7 even. And now have a look at this brilliant mating combination. It has just started basically. So now if he just takes this, if he takes the bishop, then bishop goes here and winning the queen, which is really good. And now he will go bishop to g2, and the king captures. But have a look at this brilliancy. So we're going like this, okay, and then check, and then check, and finally mate like this. So I think this is quite a pretty impressive game, assuming that Wukong has really worse evaluation function compared to TSCP, but even still he actually managed to win both on position and he was leading on time on clock for the most part of the game. Now you see, like, it's not really that big difference between the time of Wukong and TSCP, but still Wukong is slightly better on the clock. But obviously he just made it TSCP for the very first time ever in his life, so this is just why I can already celebrate this victory basically. So this is it from my side, guys, and I hope you enjoyed this very first win over TSCP by Wukong. Obviously, if TSCP would go not e4 but d4, then Wukong is losing, and all the other games, but this one ends up with Wukong actually either drawing the games or losing the games, which is not really that great. But still, my challenge was actually try to win versus TSCP when I didn't change the evaluation, but just using the bare search optimization here, and this is what I did. So at the moment, regarding the search, how the search works, so what's the difference between the search in TSCP and Wukong? That actually Wukong uses some extra techniques to cut the nodes. So here we just have a look at the score move. Sorry, not here, but here we have, if we just, okay, score moves. So he has some extra lines to detect these killer moves caused by the beta cutoffs that I've been already covering in the previous videos on this series. And well, basically this is the only difference. So the way how it played before was really slower compared to how it plays now, and that's another reason why I thought that there might be a bug in the movable ring. But now with this update regarding the sort move functions, the sort moves function, it seems like it now plays quite pretty reasonable chess, and he's slightly better because on time because of due to this killer moves are getting sorted respectively. So the next steps to add here would be to add the null move pruning, which is an interesting technique I'll be covering later on. And also I think that this particular version that I came up with regarding the sorting moves is exactly the one that I'll be using in the tutorials with the Nigimex search algorithm playlist on this chess programming channel. So this is it from my side, guys. Thanks for watching. I hope you've enjoyed the video and probably learned something interesting out of it. So see you next time and take care.